All right, I'd say, Wayne, go ahead and take it away.
All right. Can everybody hear me all right?
What? I mean, yes. Yes.
Okay, good deal. Listen, I really appreciate the opportunity to meet with the conference on Zoom, and very pleased and thankful to be able to be here and tell you about some of the things we're currently doing at my university. I think we've finally reached the tipping point, and we're over on the other side of the tipping point now, having taken on so many different things that there's just not enough hours in the day or the week to get anything done on anything, it seems like. But we're trying to make progress on that. So what I'm going to do today, rather than give you a technical presentation, is just a quick overview of the projects that we're working on that are STEM or STEAM related, if you want to add arts into the mix, of things we're doing at Athens State University over here in Alabama. By the way, it hadn't been too bad here in the Huntsville, Athens area today. We had rain early this morning and not much since then, so maybe there may be some more stuff coming, but so far we're good. No tornadoes. So let's get right into it here. There are several organizations represented in what we're doing. Of course, SARA is our uh, main backbone of the radio astronomy work we do here at Athens State and with our STEM+Sat project and so forth. But we've recently formed a nonprofit corporation called STEM+Sat.org.us, separate from the university, for the purposes of fundraising and grant applications and that sort of thing. If any of you are familiar with working with universities, things can get so convoluted in the areas of funding and reporting monies and all that kind of stuff that it just bogs things down. So we feel like we'll have a better opportunity if we do this separately from the university in terms of fundraising. Then we have our Athens State American Institute of Aeronautics and Astronautics student branch. We are about 20 to 30 students strong on any given term, and it varies from term to term because students come and go, as you know. But AIAA, most of you are familiar with it. It is probably the premier, at least one of the premier professional organizations associated with aerospace and everything to do with flight and space and rocketry and even radio astronomy and stuff too. So we have a real strong student branch, and most of the students that are working on all these projects are members of our student branch. And for the large part, most of them are taking our relatively new program here, the bachelor's degree in aerospace systems management. So you all are familiar with our first project here, STEM+Sat. We've been working on this since about 2017 when we made the proposal to this conference, which, believe it or not, was at the VLA that year. And so we first described what we wanted to do back then, and I'll tell you just a bit more about it. But basically, STEM+Sat is a 3-unit CubeSat that whose primary goals are to involve students in the design, conceptualization, building, testing, flying, uh, downloading data, all the stuff to do with a small satellite program. The secondary objective is the scientific mission, which is to receive very low frequency signals beyond the Earth's atmosphere and digitize those. We're planning to send down a digitized, basically a signal strength at any given timestamp. And we're also sending down as part of the telemetry the position of the satellite and where it's pointing. And with that data, and it's not unsimilar to what the kind of data that the the big ear back at Ohio State, I guess, was collected. Just very simple signal strength versus time and where you're pointing. Um, and then we're going to take that data, and the University of North Alabama is going to correlate that and analyze it and try to make a VLF star map or sky map of the radio sources that we pick up and their signal strength and so forth. This is kind of an exploded view of our engineering model that we've been working with now for a while. It shows the basic components. Everything's not shown here, but most everything. We're still baselining the United Kingdom Radio Astronomy Association VLF receiver board, which is number one over there. It's a real old-fashioned legacy design, but it fits within our uh, form factor, and it has some history behind it. And we're going to modify that just a little bit, but that's basically our experiment receiver. Then we're optionally looking at flying a small camera. We have a unique toroid antenna, receiving antenna, number 4 up at the top. We've been experimenting with that for a few years. It seems to be working out really well. Then we're basically using the AMSAT uh, printed wiring board set that's used in their CubeSat simulator. That's the basic electronic set that we're using. We have a 10 amp hour lithium ion battery pack and 4 deployable solar cells to charge it. And we have like a 3-watt amplifier on the transmit antenna. This is the rough block diagram of that. But basically, we receive the VLF signals, uh, do an analog to digital conversion, include that in the data set from the other satellite operational information, and download that as a telemetry signal that can be received worldwide and decoded using the AMSAT software. And we are working with students around the world to put together receiving stations that can receive the signal, record it, send that data to the University of North Alabama for inclusion in their data set and so forth. And basically, as this slide says, we're trying to bring space down to earth for kids. So the primary objective is to get students from kindergarten all the way through graduate school and college, and of course, adults who are volunteering to help with it, who are scientists and engineers and amateur radio astronomers. And for the most part, everybody's an amateur radio operator. And that's kind of a sideline that we're trying to train and get licensed as many of these kids and adults who aren't ham operators, trying to bring them into the fold of amateur radio in the meantime. Okay, the second project that have been working for several years, is on the aviation side. Our program has an aviation concentration and, of course, space systems management concentration. So this project speaks more to the aviation side. What we're looking at here is a single place experimental aircraft that we have built, and it has flown already. We're now redoing the landing gear because we found out that the landing gear wasn't quite stiff enough to handle the craft. But this is based on an Australian design that's decades old, really. It's more popular in the UK than it is here, but I think there's a little bit less than 10 of these airplanes, including ours, that have flown or flying here in the United States. It's a Corby Starlet. And if you want to look it up on the internet, you can find it. Our students have given our plane a call sign of, 'Snoopy'. So we have 'Snoopy', and 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 we have 'Snoopy' we are studying everything from avionics to air traffic control, ADS-B, position, data reporting, aerodynamics, engine performance, and so forth. By the way, the original Corby Starlet design was for like a 65 horsepower half VW engine or something like that. But we have a Continental O200 in our airplane, which has added about 100 pounds at least to the weight of the overall plane. And notice this airplane has no flaps. It does not have any flaps, and it is a speed demon. I think our first landing was made at 120 miles an hour, and that's as slow as we could get it the first attempt anyway. So we may have to put a drag chute on this thing, but top speed is about, I think the red line is about 185 miles an hour. But it's a very interesting project. The kids love it. We're beginning to do all kinds of aviation related things. Some of our students are actually A&P rated mechanics, aircraft mechanics. Some of them are in school for that down at Calhoun or other places. Several of them are, of course, pilots and in pilot training. So this is just a really good project, we feel like, for hands-on stuff for students that it's not obviously not a certified airplane, so we can get in there and play with it without too much consternations going on there. This is one of my graduates. This is Brittany Ambrose, who's graduated already. She has worked about a year now in composites for a company in Huntsville called Griffin Aerospace that are making composite type drones for the Army and other military applications. But she just recently has changed jobs, and now she's working for a company called Beyond Gravity, I think it is. So she's getting more into space. It just so happens that she's going to be a composites manufacturing supervisor over at her new job. So anyway, this is the inside of Snoopy. You can see the instrument panel there. We've got some research and development instrumentation on it, angle of attack, sensors. Of course, we got ADSB. Uh, got about as much in the avionics as we have in the rest of the plane. But you see little Snoopy over there on the right. He is definitely our mascot. Okay, the third thing that we're working on goes back to the space concentration in our program, and that is a portable life support system for Mars surf.
Try again.
Oh, hush, Siri. Me and Siri don't get along all the time. I have to mute that thing almost.
But there's nothing playing.
Exactly. Okay, well, I'm going to put my watch on the other side of the room here. It tends to take off the conversation whenever it can. Anyway, so we have conceptualized several years ago now a portable life support system to support the new trend in spacesuits. And the lady you see standing in the middle of this slide is Dr. Dava Newman, who was recently the associate administrator at NASA several years ago. She's back at MIT again now, I believe. She's also working with one of our adjunct professors that I'll tell you a little bit more about now. They're friends. But anyway, she has been developing a new spacesuit concept that instead of using pneumatic pressurization to provide the pressure against human tissue that you need in like a vacuum environment, she is using mechanical means based on something almost like a compression garment. But all the little lines and stuff you see on that are highly engineered wires that provide compression to the body at critical points, and they actually do a computer analysis of every astronaut and come up with it. And on the spacesuit, the main thing is to make it more lightweight and easier to function in than the old suits used to be. And so that's one of the trends. And so our concept for a lightweight backpack is based on high-tech scuba diving technology, based on rebreathers. And the Dive Right company is our teamed with us on that. They make probably one of the world's most elaborate and advanced high-tech scuba diving rebreather. This is not it. This is a couple of years old technology that you see here, but the concept is the same. So anyways, we're building a prototype of this and hope to do some testing. And we have been working over the last year with Marshall Space Flight Center to get a Space Act agreement in place so that we can do testing and different student internships and stuff at the Marshall Center. So we're working that and hope to test our backpack out there. Project number 4, some of you guys have seen this before. This is a portable satellite tracking trailer called Steamroller that we have put together over the last few years here at Athens State. And we've been using it for everything from communications through all the amateur radio satellites, the space station also included, for instance. We've recently been doing some moon bounce uh, experimentation with that. And of course, the antenna that you see here is just a couple of sets of the Arrow brand UHF, VHF Yagis, but that's not what we're trying to do moon bounce with. We've got I think it's an 18 element uh, double beam, and I think it was on the picture. Maybe if it's not, I think there might be one in here that we bought from Serbia. Some of you are familiar with. I think it's Antennas and Amplifiers might be the name of the company in Serbia. Gosh, they make a great antenna. Best antenna that I've run across. So anyway, we're using that. So we're planning to do that along with radio astronomy. And we've got several things that we hope to do with that. Here you see Bob Arisman and Tim Cunningham inside the steamroller trailer. We have a geochron in there. We have a ICOM 9700 and a sat box and all the stuff you need to communicate through the satellites, track the satellites, and so forth. And we're hoping to use this along with some other equipment to track our CubeSat once it's in orbit. And so we've had quite a lot of work. We carry this trailer to local uh, middle schools, high schools, elementary schools during their STEM uh, conferences and presentations that they do and demonstrate amateur radio satellite communications and talk about our satellite project and so forth. And it's turned out to be a really popular thing. We've actually last year we took Steamroller to Sun and Fun down in Lakeland, Florida, and we were able to set up right outside the new technology innovation pavilion. And boy, we had a lot of positive feedback and kids of all kinds and adults stopping by and so forth. And we had a couple of ham stations going on the side besides all the steamroller satellite stuff. So it was a very popular thing and worked out very well. So steamroller is going to be an essential part of our satellite program, radio astronomy satellite program, of course, in terms of trying to track and record data from the satellite. And this is a picture of Steamroller out in the boondocks. We keep it, and when we try to do the moon bounce, we found the noise level around campus here is just too overcoming to try it here very successfully. So we set it up out in the boondocks down around Decatur, Alabama, Priceville, Alabama. And what you see there is part of the big antenna. That's not the whole antenna, I don't believe. That's about maybe 2/3 of it. It's a huge antenna and has a lot of really good gain, and it does a good job. So that's Steamroller, and it was originally the actual physical trailer part of it was funded by uh, Toyota, Mazda Toyota factory here in Huntsville with a grant we got from them for the trailer, and we bought some of the I think we bought a couple of the radios with that, and a lot of it has just, like always, been uh, from our lunch money. So we probably got about as much invested in the trailer as anyone else, just personally between all the people working on it. But it's a labor of love, and it really impresses the kids. We have solar cells that we set up when we're portable. We got gasoline generators, of course. We've got a lithium ion uh, battery storage system that we use, and it works out pretty cool. And finally, here is our newest, it's not our last, but it's our newest project. About a year ago, we got in contact with some individuals up in near Notre Dame in South Bend, Indiana, that had this 30-foot dish for sale. And of course, it was unassembled and everything. And so we purchased the dish, and everything that we could find that may have gone with it, and have transported it to our boondock facility near Priceville, Alabama. And now uh, we're in the process of writing a grant for ARDC to get some money to pay back what we owe on the transportation. So we're in hock around 8 grand right now to get that paid off. But we are working with the Von Braun Astronomical Society and hoping to set up the dish on Monte Sano Mountain right next to the Von Braun Observatory and Planetarium building. And we are in the state park. We'll be in the state park, Monte Sano State Park, right next to the camping grounds. And there are literally thousands of people that go through that facility. And if any of you have been or plan to or wish you would come to the Huntsville Ham Fest, which is in August, a lot of activity is done up on Monte Sano, POTA in the park, and all kinds of other stuff going on. And we hope to make radio astronomy a big part of that once we're able to get this 30-foot dish set up and operational. So that's our latest project. And we're always soliciting people who are interested. We're trying to entice people around the world. And so far, we have people supporting us in the UK, a little bit in Australia, although I don't think it's the same gentleman that did a report yesterday. I did a presentation. I don't think he's part of the group, but I'd have to check that out. Maybe he can be. We've got Hawaii. We've got South Africa, and we've got a scattering of folks all over the United States. We are putting together a what we hope to turn out to be a worldwide amateur radio network supporting our satellite project. And it's going to be based, the net control for that's going to be at Brea College up in Brea, Kentucky. Deanna Wilburn, I think, is the person that's in charge of that. She's a member of SARA. I don't know that she's participating in the activity this weekend. I didn't see her in the list of Zoom members, but she might be here. I'm not sure. But if she is, speak up, Deanna. And she's been working there at the university to set up a very large scale amateur radio and radio astronomy contingency at Brea University. In Brea College, I guess it is, and they are a unique educational institution because all of the students work at the college and pay their tuition by their labor. And I've never heard of it before, but it sounds like a really cool thing to do. So all of the students work for the college, and you can imagine they're a very motivated group of people and students and faculty, and seems to be going really, really well. So we hope to get that amateur network net control station set up there soon. And we have a new mission operations and control center, and I should have put a slide in here on that. I'm up in the third floor of my building right now, but our mission control lab is downstairs. We also use it to simulate rocket space program missions, and we have a couple of courses in our degree program that require the use of that lab. And so we have a communications center down there as part of that, where we have amateur radio, a 1 kilowatt station, sideband, CW, data, all that set up in our mission control room. And once we get everything going, Deanna gets her setup going, we'll be offering everybody the opportunity to start participating in that ham STEMSat network. So there's all sorts of opportunities to collaborate not only with SARA, but other organizations. We're hoping to brief the National Space Club here in Huntsville within the next month. We're working with the Von Braun Astronomical Center, of course, and Gigaparts Electronics Store. A lot of you guys have heard about them. They're supporters of some of our activity. University of North Alabama with Mel Dr. Mel is part of the group, of course, who's presented before. And we're also doing additive manufacturing. Some of the satellite components, as you noticed probably in the engineering model, are 3D printed. We're doing space environment studies. Hope to do some of that at NASA. Marshall, some of the environmental testing of our hardware. Some of our students have been studying satellite deorbit technologies. And of course, we're teaching space mission project management and space systems program risk assessment. I just put in a proposal application for a new graduate certificate program here at Athens State University that will offer a graduate level certificate in space systems management. And it has 5 courses that make up that certificate. And those 5 courses are aerospace program management. And we happen to have a name familiar to all of you. Lori Wingate has just come out with a new version of her project management book for research and development. Lori will be teaching that class. She's currently an adjunct instructor for us, but that's a new course that she's going to be teaching in aerospace program management based on her new textbook. Another class in that certificate is space frontier management. And that sounds like a training for Starfleet personnel, doesn't it? Well, it is a little bit like that, but it basically gives an overview of everything. Well, maybe not everything, but a lot of what's to do with deep space exploration and colonization. How do you manage a program with humans that's millions of miles from Earth? And, you just can't pick up the phone and call them or talk to them on the radio. I've got all kinds of different things to deal with, not only the space law, international and domestic, all that kind of thing. Another one of the courses is Advanced Aerospace Propulsion. We have a lot of propulsion research and tests going on in the Huntsville area. Of course, Blue Origin is building their BE-7, BE-4 engines here, supplying them to United Launch Alliance, which is in Decatur, Alabama, just 13 miles or so down the road. And we've got a lot of other experimental work going on in propulsion here in Huntsville. So anyway, we're teaching that course. Also, I mentioned one of our students is working in composites, and one of our new certificate courses is in aerospace composites. We touch on it in another one of our classes, but this is going to be really hands-on, nitty-gritty, and bring some of the students out into the labs at Marshall Space Flight Center and into some of the companies like the Griffin Aerospace, which we have several graduates working there already, in addition to Brittany, who now works at Beyond Gravity in composites. So we're going to teach people not only what composites are, how they differ from metal or metallic structures, different kinds of construction methodologies, design and tests of composite structures, tanks, other sorts of structures, and of course, inspection and sustainment. Damage assessment is a big thing when it comes to composites. And then something really excites me. Another course in that space certificate program is small satellite development. So we have a graduate level course that addresses all the issues we've been dealing with over the last few years in getting STEM+Sat to become a reality. So that should give our students a whole lot to do. And we hope to have a lot more student papers maybe this time next year. Some of our students are currently members of SARA, but we didn't have any student papers presented this time, and I apologize for that. And again, admittedly, I think we're in over our heads here with a limited number of faculty people supporting all that we're doing. It's not a good excuse, but that is the excuse. But anyway, so all kinds of opportunities. We're going to publish our papers in a university journal that's published once a year. So that's going to be something. I mentioned that we're hoping to develop the ground tracking network capability, and we're going to be doing that in coordination with SatNogs. And Bob Arisman, I don't know if Bob made it online to the conference or not, but Bob is more versed in all that's SatNog, but is basically a volunteer global ground station network. The neat thing about SatNogs is that they use, to some great extent, automated equipment. You set the tracking equipment up, and computer programming allows it to know when the satellites of interest are coming within range, and it turns on and tracks and records the data and all that. And we feel like that would be very beneficial to our STEM+Sat project. So Mel Blake, Dr. Blake over at University of Alabama, is currently writing a grant to get funding to start putting in place more SatNog type tracking stations in the state of Alabama and in the U.S. in general. I think we only have one or two, maybe three at the most, if that many, sat-nav tracking stations in the whole state of Alabama. And we'd like to see that expanded and put more and more in the continental United States. There are a lot of them all over Europe and around the world. Not so much here, as it turns out. So in summary, rather than keep you guys too long, but at least it's giving you some peace and rest for your lunch to digest maybe a little bit. We have a lot of unique things going on here at Athens State University. A lot of STEM-oriented things, experiential learning. One of the things I'm going to mention in the next 2 or 3 bullets down here, we're working with Marshall, is pretty far out. And students are going to be able to participate in so much of this, not just locally, but all over the world. The opportunities there to become involved and be part of the STEM project and some of the other projects too. So we hope to continue to build that cadre of support people around the world. Some additional things are going on, and we are really big. We have a whole group of faculty that is dedicated to implementing experiential learning projects here at the university and make it a serious part of classwork, hands-on learning. And I think all of you agree that you learn a lot more when you're able to put your hands on something, build something, test something, at least see something, and have a physical experience to put together with your textbook learning. So we're pushing that very hard. Our latest experiential learning project is called Project Moondust, and we're collaborating with Marshall Space Flight Center on this, and it addresses collection, analysis, and mitigation of risks associated with lunar and Martian regolith. And you all have heard, and maybe a lot of you know a lot about this, where the very fine dust that's on the moon and to some degree Mars as well is very disruptive when it gets into the equipment. It's toxic if it gets into your lungs. It's very difficult to clean off of your spacesuits and uh, equipment of all kinds. And so anyways, it's like very high on the NASA to-do list of technology that's got to be built to deal with some of the things going on in deep space exploration and colonization particularly. And I think it's like 187 out of over 500 key technologies or something. Maybe it's less than that. Anyway, so we're participating with that. One of our adjunct instructors, MJ McGraw, who's in California, is going to fly on one of the NASA Vomit comets next spring. And we hope to fly a test article with her that she is going to be able to take out, and they're simulating moon gravity, 1/6 Earth gravity. So we're developing a concept and an experiment for her to take on that type of thing. We hope to have a student fly with her, and should be a wonderful experience. And then there's a chance we might, depending on the success of that endeavor, we might get that prototype or something similar to it on the space station, possibly before it gets deorbited. And of course, we're continually developing additional areas of research. We're working with the Air Force, as a matter of fact, to implement Air Force ROTC here at Athens State. They've just gotten it set up at University of Alabama, Huntsville. So we would be part of their hub, and our students would do all their PT and Air Force classes probably over at UAH, along with other local community college and university students who might want to become a part of Air Force ROTC. And I have on pretty reliable sources from the Air Force that Space Force is definitely moving to Huntsville, Alabama. And they've been out on Redstone Arsenal negotiating with the FBI, who is also established here in Huntsville now. And the FBI came in and put dibs on a whole bunch of property on the arsenal and so forth. So I understand now that the Air Force and the FBI may be negotiating on who has access to certain properties on Redstone Arsenal. So we hope that gets officially announced. I think it was supposed to have been announced officially by now, but I have not heard it. But anyway, from reliable sources, I hear it's going to happen. So that'll be a big boost for everything we do. And the Air Force people are more interested from a Space Force standpoint in what we're doing with our satellite and with the backpack and with this dust project than they are in what we're doing aviation wise, I suspect. But anyway, so in a nutshell, that's some of the things we're doing, and there's also some other informal things going along at the university that I'm not going to talk about, but we are not bored. I can certainly tell you that. There's so much happening here that's unconventional that you would not expect to see coming out of a college of business, which is where we operate. It's unusual, but we have support from the administration, and to some extent, uh, we certainly have support from our dean within the College of Business, and we're hoping to get more faculty hired to help us do some of the things that we're working on. It would be much better. So with that, I will open it up to any questions. And again, I sure appreciate Rich and Ken the opportunity to present this little overview. And I've been watching some of the SARA presentations. They're great as usual. And hopefully we'll be online or in person next year with some more technically oriented presentations. Thank you.